Hello, everyone. Thank you for attending our RAM Forensics project presentation. This is Saleh Ahmed Alhawas.
Ahmad Alattas.
Olotu.
And Austyn Gerzevske.
Our project's achieved end goal is to perform a black box memory forensic analysis. Therefore, we start our project process by replicating two forensics analyses of two different malwares in order to get acquainted with the forensic tool we'll be using and with the forensic process. Before diving into the project, there are terms that must be introduced. First, memory or RAM, which is a fast information storage device for running programs and their data. Also, volatility, which is the forensic tool we'll be using for which analyze and inspect memory dumps. Malware, which is any malicious software that causes damage. There are also SRAM, which is static random access memory, and DRAM, which is dynamic random access memory. Lastly, volatile storage, which is any storage device that needs continuous power supply to store data. For storage devices, there are two main types of them. First, non-volatile storage, such as hard drives, SSDs, and BIOS system storage devices. Second, volatile storage like cache, CMOS, and RAMs. And as introduced before, RAM storage has two types, static and dynamic. Here we have simple comparisons to illustrate the difference between these types. At first, between types of storage. Non-volatile can store data permanently, and unlike volatile storages, it does not need continuous power supply for that. Also, even though volatile storages don't have file systems like the non-volatile ones, it is tremendously faster. And between types of RAMs, the main difference between them is that unlike static RAM, dynamic RAMs needs a continuous power refresh to hold data, which takes from its speed, thereby increases the price of static RAMs. Static RAM is mostly used in CPUs as caches, whereas dynamic RAMs in PCs as the regular RAM sticks we buy. This project focuses on dynamic RAM forensic analysis. Hence, we'll first present the general idea of how it comes in play in our computer's architecture. Let's suppose we have a counter that we use to prepare our dinners. Our cooking ingredients are in our pantry, so we'll need to travel back and forth every time we need any ingredient. This will slow the cooking process. However, if there is an upper cabinet, we can move all the needed ingredients for our dinner to it, which will almost eliminate travel time and increase cooking speed. This is the same exact methodological concept that is being used in computers where RAM holds all process-related information that is being under processed in the CPU. These related information are copied from the main storage device, which is the non-volatile storage device, into RAM for speed and efficiency purposes.
Okay, to begin talking about RAM forensics and malware forensics, I'll first talk about RAM forensics. So the reason why it's important and why it makes sense to look into is that RAM forensics, there's a lot more data than there might have used to been many years ago. There's virtual machines, operating systems and applications that use lots of RAM, and then also just machines themselves have gigabytes of RAM to look into. So there's a lot more data that can be there to actually be investigated. It's interesting for a couple of reasons, actually, and those primarily are problems with it. So the first thing is that RAM is power dependent. So if the machine is turned off or is moved and then turned off, you would lose the data that's in there. So it needs to be captured before the power is removed. The second problem is that RAM is very fast. It can read-write any order. So it's hard to capture an actual static image of RAM if it's always changing. And then if every time you do a scan of it, it potentially is different than the last. And the third thing is that malware can live in the RAM itself, or it has a lot of processes that can be running that are just stored in RAM or leftover artifacts from that. So malware itself actually integrates with RAM, and it can kind of be hard to miss, which we'll actually see here. This also makes it kind of interesting is that you could be scanning, you could be going along, and the malware is at the end. By the time you get to where the malware was, it already hopped to the beginning because it can just rewrite in any order, and you completely missed it when you were scanning. So this is another thing that makes malware RAM forensics interesting. To go more into memory acquisition itself, it's basically the process of capturing memory state, processes, information, and files for future forensic analysis. You're trying to capture artifacts or actions that are left behind by malware, or potentially the malware itself. You can use that for investigations, mediations, and research. And then there's also information that you're not going to find anywhere else, so it's good to capture memory. To kind of look at a little bit of like a forensic investigation, some of the things you want to do is make sure you ensure the integrity of the digital data and the physical hardware. You can use hashes for the digital data. You want to run multiple memory scans for the reasons from before, is that it's potentially changing each time. The malware, you might miss it. You want to run a couple scans. You want to make sure that those are redundant in case something happens to them. And then also maintain the integrity of the device when you're scanning it. Don't unplug from the network, don't unplug the power. There are a couple of techniques. They include cold boot and live acquisition. We're primarily going to be looking in live acquisition type scenarios. And then there are common tools, FTK Imager, WinPMem, and Memorize. We briefly looked into those before this. As a high-level overview, FTK is easy to use. It has GUI. It's nice. It's quick. WinPMem is slower, but it's all right. And then Memorize was the slowest one, but it was potentially the most powerful for scripting purposes. Is that it's just a bunch of files, and we could change them and script them and combine them together to make something more complicated. As a high-level overview of a summary of what we'll be talking about is basically we acquired images from Volatility's GitHub. We installed the Volatility framework, and then we performed the malware analysis. We were primarily using Kali and Ubuntu for this.
Okay, we are gonna do the investigation on the image called Mazis Fuzzy Hidden Process, and we gotta know what is it and what it does and how to protect yourself from. That's what we're gonna discover in the next slide. Here we're gonna start the process. Before starting the process, we need to have two things. First of all, the image that we gonna do the image acquisition, we get it from the GitHub page, and you have to have the installing volatility framework. And after that, we can start the process. And first of all, we can start with the image info. With the image info, we can know the general information about this malware. And as you can see here, we can see the suggestion, the platforms that it could run it, and some more information, so the time that it was taking, and some more details. And after that, we can start the process on this image. First, we start to do the PS list. With the PS list, we can see it can list all the processes that were running while that image was taken. And as we can see in the process ID, there is nothing suspicious yet. And utilizing BSX view to find that's specifically utilized for the hidden files. And as we can see here, before doing anything, we can recognize that there is something here with that result with the network listing. There's something with false in the PS list and PS scans, which make us suspicious actually. And the process ID was hidden as 1696. And now we can see the open connection just to ensure what if there's anything more that we could think about it. And from here we can see when we try the scan, it shows us the same process ID that we were suspicious with, which is the 1696. It was connected with the remote address through port 1158. And then we tried the socket to have more information about that process ID, and we can see the second image. It shows us some the offsets and the process ID and the port. After that, we try to do the who is to know where is that IP is coming from, or who has this IP. And when we tried it, we found that the organization name was Internet Assigned Number Authority, and the address that was utilized, and the city, and even the states, and some more information such as the postcode and which country it's coming from. And then we try to do two things, which are process in the process memory, which is memory dump and process dump. And the memory dump, we dump all files. We dump the file, and we can see that we extract all memory resident pages in the process. And then we try to do the process dump to check that it's executable. And then we tried to string grab, and when we tried after dumping that file, we want to see what inside that file. And from here we can see there are a lot of executable files and the root that it is in, and there's the IPs and more details about the DLL file. And after that, we took that dump file, and we put it on VirusTotal. And when we check it, we see that there is a malicious inside it.
So after taking the process memory dumps, we did look at the DLL dumps as well. And here is a list of all the DLL dumps of the process 1696. We put it into VirusTotal, and we found that 4 of those DLL dumps did contain malicious content. After taking the DLL dump, we looked at the process privileges to see if any had been enabled explicitly. And we found 2 of them, which was the load and unloading device drivers, and then removing computer from the docking station. There were other privileges that were escalated, such as the time and the logs as well. After that, we looked at the registry, lastly, using the user assist command. And the user assist pretty much, like I said, provides additional registry-based information. So what it does is it pretty much helps you find programs and files that were opened by the user. In here, that will be the attacker. And here we can see the network listener executable on the desktop in a particular folder called MOIX, which is the malware. And this concludes the entire process of our malware analysis. And now we're going to go into our analysis conclusion. So because of the port that was pretty much remotely connected when we did the con scan, we saw that the malware was likely loaded via SMB because the ports were 445 and 139. We suggested RPC connection. And we do know that SMB is a network port file for sharing. So there's definitely some data that is being transferred that the attacker is transferring. And other things that the attacker manipulated, were system resources such as modifying the disk space, network configuration, the device drivers, and there was also a binary execution using C language to cause buffer and heap overflow. After this, we're gonna then, now that we've looked at the malware analysis of this hidden process, we know more information and we know what it is, which is a Trojan that hides this process while installing additional malware. And what it does is that it installs a network listener to check for connection requests, pretty much waiting for a client to connect to a port. And once the client connects to that port, it hijacks the session and pretty much, is able to do anything by manipulating system resources and stealing information. And how do we protect ourselves from this malware? Using antivirus and anti-malware. Pretty much the signature can help protect against the known malwares, whereas heuristic-based solution can help protect against anomalous behavior. Browsing and email security, best practices to protect us from common vectors. So always check your links, don't download unknown files. Finally, we're going to talk about how this malware differs from the other two that might teammates talked about earlier, the two that we analyzed initially, which was Zuis and Crydex. So for Moyix, we know that it's a Trojan that hides itself while it installs additional malware. Zuos, we know that now it's a Trojan that targets Microsoft Windows, and it pretty much steals banking information, and the same is with Crydex as well. And Moyix required more from our investigation procedure, as Moyix process was hidden while the others were not. So we had to do more digging versus Zuis and Crydex, where we could list the process and we could see that there was something very fishy about the processes. And just to recap our project goals, which is memory RAM forensics. Pretty much we're trying to achieve gray black box malware forensics assessment, which we did using Moyix hidden process. And we wanted to understand, what goes into malware analysis, forensics, and we're able to perform this memory and analysis of the malware using Volatility framework that we installed to do the project. And this concludes our presentation. Thank you for listening.
Thank you.
Thank you.
Thank you.